I'm going to tell you about renewable energy. Renewable is the capability to replace or reproduce and reclaim. The energy which cannot be exhausted with their usage is known as renewable energy. Renewable sources will be recreated in near future. The generated energy can be directed use or it can be stored in batteries. Renewable energy can be produced by collecting different forms of energy from different methods from various sources. Some renewable sources are solar, wind, biomass, hydroelectric, geothermal, tidal, and so on.
Next, I will talk about explanation of relevant to scientific instrumentation application concept. Scientific instrumentation plays a very important role in a renewable energy system because it enables accurate and effective monitoring, control, and optimization of the system operation. The example application concept. Firstly, we have solar energy. The important instrument for solar energy is pyranometer that will measure sunlight intensity. Next, we have PV panel with voltage and current sensor. This will calculate the efficiency of converting light energy to electrical energy. Next, we have application concept, an automated system that monitors the output of the solar panel and adjusts its position based on the sunlight intensity. Next, we have wind energy. The important instrument is anemometer that will measure wind speed. Next, we have wind that will determine wind direction. And the application concept is wind turbine will only operate if wind speed are within a safe and efficient range, typically 3 until 25 meter per second. Next, we have hydropower. The important instrument is level sensor that will measure the water level of them. Speed sensor to detect the speed of rotation of the turbine. The application concept is control of the opening of the water gate based on water level and energy requirements. Next, lastly, we have biomass energy. The important instrument is the temperature pressure sensor. This will control the combustion or fermentation process. And we have flow meter that will calculate the fuel or biogas flow rate. This application concept is automatic control system to maintain optimal temperature in biomass reactors.
Let us now examine the various applications in renewable energy in modern context. First, we have electricity generation. Electricity can be generated from renewable source in multiple ways. Solar photovoltaic system converts sunlight directly into electricity. Wind turbine harness wind energy to rotate generator. Hydroelectric power plant use the kinetic energy of the flowing water, typically through dam or river, to generate electricity. Second, we have heating and cooling. Renewable energy is also used for heating and cooling purpose. Solar thermal panel heat hot water for residential or commercial application. Biomass boiler utilize organic waste to produce heat. Geothermal heat pumps are particularly efficient in maintaining stable indoor temperature throughout the year. Third, we have transportation. In the transportation sector, biofuels such as ethanol and biodiesel are used in vehicles, including cars, planes, and ships. Hydrogen fuel cells produced from renewable energy sources are also used to power hydrogen-fueled electric cars. Lastly, we have off-grid and rural application. Renewable energy systems play a vital role in providing electricity to off-grid and rural areas. Solar power, microgrids, and home solar systems are increasingly being utilized to provide electricity in areas where grid access is unavailable. Additionally, hybrid systems that combine solar and wind energy are employed to power infrastructure such as telecommunication towers and irrigation systems. Next, we will explore several notable real-world implementation of renewable energy technologies across different countries. Let us begin with Denmark. Widely recognized as its global leader in wind power, over 50% of Denmark's electricity is generated using wind turbine. A prominent example is the Mølleåen offshore wind farm located near Copenhagen, which is the result of successful collaboration between the public and private sector. Moving on to China, it stands as a renewable energy superpower. China leads the world in installed solar and wind energy capacity. Furthermore, the country is home to the Three Gorges Dam, which is currently the largest hydroelectric power station globally. Next is India, which has made significant progress in solar energy development. The Butler Solar Park in Rajasthan is one of the largest solar parks in the world, with a capacity of approximately 2.25 gigawatts. In addition, India has initiated the International Solar Alliance to promote the use of solar energy in tropical regions. Lastly, we turn our attention to Iceland, a country that has successfully capitalized on geothermal energy. Nearly 90% of Icelandic homes are heated using geothermal source. Additionally, the country generates the vast majority of its electricity from a combination of hydroelectric and geothermal energy. A prime example of this success is the Happy geothermal power plant, which is visible on the slide. Located near Reykjavik, is one of the largest geothermal power stations in the world and supplies both electricity and hot water to the capital region.
Here's some benefits of renewable energy. First, reduce air pollution. Traditional energy sources release sulfur oxide and nitrogen oxide, contributing to air pollution and health issues. Renewable energy sources generate power without harmful byproducts and leading to cleaner air and better public health. Next, water conservation. Unlike fossil fuels, power plants that require substill water for cooling, many renewable energy systems consume significantly less water. This is especially important to regions facing water scarcity, as it helps conserve this vital resource. Last but not least, improve economy. The renewable energy sector offers a range of employment opportunities, from manufacturing and installation to research and development. Challenges in implementing renewable energy. First, high installation costs. Initial investment in renewable energy system can be expensive, often involving significant upfront expenditure for solar panel, wind turbine, or other green technologies. Next, lack of knowledge. Many individuals and businesses may lack of the knowledge and understanding of renewable energy technologies and their benefits. This lack of awareness can lead to skepticism and hesitation to embrace clean energy solutions. Lastly, lack of power storage. Some renewable sources such as solar and wind produce electricity when the sun is shining or the wind is blowing, but not necessarily when energy demand is highest. Efficient energy storage solutions such as advanced batteries and pumped hydro storage are essential to store excess energy when it's abundant and release it when needed.
Future developments and innovations. Renewable energy is used for future developments because of its abundance in the environment and emit little to no greenhouse gases, which reduce the pollution in air. Although all renewable energy have its own future capacity, solar energy offers more variety as most parts of this world are exposed to sunlight. China is expected to register the largest installed residential solar capacity in the world by 2024. With the strongest per capita growth in Australia, Belgium, the Netherlands, and Australia. By Emily Ford, 2021. Some of the developments and innovations according to Energy Tracker Asia. The first one is floating offshore wind farms. Floating wind turbines is placed in deeper waters where winds are stronger and more consistent. It will increase the global wind energy capacity as it reaches commercial scale. Second one, enhanced geothermal systems or EGS. It injects fluids deep into the ground to create an artificial reservoir, harnessing the Earth's natural heat to generate electricity. The third one is hydrogen fuel cells for home energy storage. It is well suited for powering homes and small businesses, especially in remote areas with limited grid access. It offers longer lifespan and higher energy density. The fourth one is bioenergy with carbon capture and storage, BECCS. It burns biomass to produce energy while capturing and storing the carbon dioxide, effectively reducing the carbon footprint to near zero. Next is tidal energy turbines. It allows turbines to capture energy in even lower velocity tidal flows, increasing the number of viable locations for their deployment. It is expected to drop costs and increase production efficiency. Next, green hydrogen. It produced through electrolysis powered by renewable energy and is a promising solution for decarbonizing industries and achieving global climate goals. It generates no greenhouse gases during production, making it entirely clean. And the last one, AI for renewable energy sector. It will optimizing energy production, improving grid management, and predicting demand with unprecedented accuracy. It will enhance grid efficiency by balancing energy supply and demand in real time, minimizing wastage and reducing costs. To conclude, renewable energy is the key to a sustainable future. By adopting this technology, we can reduce our dependence on fossil fuels and protect the environment for future generations. Embracing these solutions is not just an environmental imperative, it is also a strategic and economic opportunity for the future.